I'd like to discuss with you an attempt which we are making to combat the greenhouse effect and to reduce the carbon dioxide concentration of the atmosphere. We call this project carbon negative, and it involves the use of biochar. The problem is that the carbon dioxide concentration of the atmosphere is increasing, and this is thought by many to be a result of burning a fossil fuel. This is thought by many to be due to what is called the greenhouse effect, which involves the re-radiation of light from the sun by the earth and then reflected back by a layer of gas, largely carbon dioxide, in the upper atmosphere. Here we have listed some of the possible consequences, which includes the melting of the Arctic ice due to the increase in temperature. This could lead to the flooding of land, such as in this populated area of Florida, where many people will be displaced. Well, then, what can we do to reduce this greenhouse effect and reduce these gases in the atmosphere that are giving us trouble? Here are some things that we might do to decrease the production of carbon dioxide. We could use alternate fuels, or we could decentralize power generation and get rid of the CO2 generated by liquefying it, burying it, or sequestering it. But the better approach would be to remove the CO2 to begin with. One way to get rid of the CO2 is to liquefy it and pump it underground, but the problem is we don't know about the stability of this and the availability of places to do it. We could chemically bind the CO2, but the technology of this and the cost is still uncertain. The best approach would be nature's way of using photosynthesis. With photosynthesis, light from the sun shines on plants and causes them to absorb carbon dioxide and water, which get converted into organic materials, which then serve as biofuels. Plant material can then be heated in limited oxygen and gets converted into biochar, a form of carbon which is very inert and can be buried in the soil where it remains for an indefinite period of time. Thus, carbon dioxide is removed from the atmosphere and converted into a solid material, biochar, which is stable. There's concern about the energy that is required. Some energy is required to get the process going, but then the volatile gases produced generate enough energy to continue the pyrolysis, so there is no net energy necessary. It appears that the energy content of the biomass is more than sufficient to keep the process going. Concern is whether or not there is enough biomass available. The Department of Energy and Department of Agriculture suggests that there is sufficient renewable biomass for the purpose. We must also be concerned as to whether the crops will be growing fast enough to be renewable. There are fast-growing crops which should be sufficient for this. Another advantage of the technique is its benefit to agriculture. Natives in the Amazon many years ago have used it, and this is referred to in an article called Black Gold of the Amazon. Here are some pages from an article where it is shown that growth rates can be increased many-fold by addition of biochar biochar to the soil. Furthermore, fertilizer use is reduced. Thus, it appears that we have a win-win situation. We're not only removing carbon dioxide from the atmosphere, but we're benefiting agriculture, reducing fertilizer use. The process is clean and is a net producer of energy which can be locally used. Our approach is summarized here. We hope to start small and have simple and small units on individual farms so that they're close to the area where the biomaterial is grown. Some energy will be required to start off the process, but enough volatile and flammable gases will be produced to keep it going. The biochar which is generated would be locally used by farms in the region where it is produced. Our hope is that we will build a simple and cheap enough pyrolyzer for the average farmer to use efficiently. And if successful, we hope that this will stimulate further support to expand the effort. If this is successful, it could have a significant value in improving soil and decreasing carbon dioxide concentration in the atmosphere. It should be an environmental plus.